Hello students, welcome to the math class. Students, we have started the chapter Permutations and Combination, that is related to the arrangement and the selection of the objects. Now under this chapter we have completed one objective, that is factorial and its application. Today we are going to start with the second objective, that is fundamental principle of counting. Then we will complete third, application of the permutation formula in the sums. Then fourth, permutation, when all the objects are different and when objects are not different. Let's start with the example of second objective, that is fundamental principle of counting. In how many ways can two prizes, that in social science, history and maths, be awarded to the 15 students? Now here prizes are 2 and students are 15. So we have to check in how many ways these two prizes can be awarded to these 15 students. And second case is there, in how many ways can the first and the second prize in history be awarded to 15 students? Now in this question, two cases are there. So I will discuss the first case first. In first case, total students is equal to 15. And number of prizes we are having 2. It means we have to fill 2 places. Now, for the first prize, we are having 15 choices. That is, number of choices for the history prize, it is equal to 15. Now, one student may get 2 prizes also. So, number of choices for math students, again it is 15. So, total number of choices for awarding the student is equal to 15 multiplied by 15, that is 225. Now, next case is there. In how many ways can the first and second prize in history be awarded to the 15 students? Now, in this case, we are giving 2 prizes in the same subject. So, here one student will get 1 prize only, either first prize or second prize. So, again, here number of choices for the first prize is equal to 15. And the number of choices for the second prize is equal to 14, because here no same student will get both the prizes, first and second. So in this case, total number of choices is equal to 15 multiplied by 14. So total is 210. Now there is another method also for solving this question by using the formula of the permutation, because here we have to see how many choices are there. So again here total students is equal to 15, that is the value of n, and number of students required for prize, that is 2. So this is the value of r. Therefore total number of choices we can find by using the formula of NPR. Now NPR formula is, we have already discussed, it is n factorial upon n minus r factorial. So here n is 15 and r is 2. So when you put the value, you will get 15 factorial upon 15 minus 2 is 13 factorial. Now 15 and 13 are nearby factorials. So we will simplify the 15 factorial, bigger one. So it will become 15 into 14 into 13 factorial, and denominator 13 factorial is as it is. Now 13 factorial cancel with 13 factorial. So answer is 15 multiplied by 14, that is 210. So we can do this question in 2 ways, either by the principle of counting or secondly by the application of the formula. Let's do next example for better understanding. This example is related to the words. So, how many words with or without meaning can be formed with the letters of the word equation so that the vowels and the consonants occur together? Now here, word is given equation. Now when you count it, 1, 2, 3, 4, 5, 6, 7, 8. Here total letters in the word is 8. So we are having 8 spaces here to fill. Now in this word, number of vowels is equal to 5. That is E, Q, A, I and O. And number of consonants, that is left out letters, that is Q, T and N. So 3 consonants are there. Now we have to form the word so that the vowels and consonants occur together. So here we will consider all the vowels as a one letter. We have combined them in one box, that is E, U, A, I, O. This is one letter, and the consonants as the second letter, that is Q, T, N. Now these two will come together. It means we have to see the arrangement of these two letters. So total letters here we are having 1 plus 1, that is 2 letters. Now there are 5 vowels in the first box. So these 5 vowels can arrange themselves in 5 factorial way. So 5 vowels can be arranged in 5 factorial way. Similarly, 3 consonants can be arranged in 3 factorial ways. And finally, we are having 2 letters only because we have considered all vowels as one letter and all consonants as one letter. So total arrangement is equal to 2 factorial. So total possible ways can be calculated by multiplying all these factorials. So it is 2 factorial into 3 factorial into 5 factorial. Now 2 factorial can be written as 2 into 1. So answer is 2. 3 factorial can be written as 3 into 2 into 1. That is 6. And 5 factorial can be written as 5 into 4 into 3 into 2 into 1. So it is 120. Now 6 2s are 12 into 120. So answer is 1440. In this way we can find the total possible ways in which the letters of the word equation can be arranged. Let's do one more example. When the letters of the word repeated. Now for example, in how many ways of the distinct permutations of the letters in Mississippi will arrange so that the 4 I's do not come together. Now 4 I's not come together. Whenever the case is there for not coming together, we will find total permutation and the ways in which they are coming together, then subtract. Let's start with the solution. Total letters in the word Mississippi is equal to 11. Now you can see I is coming 4 times. So number of I's is equal to 4. Similarly, number of S is also 4 and P is coming 2 times and M is coming once only. So total number of permutation in this case, when the letter is repeating, here it will become firstly total letters in the word, that is 11 factorial. Then it is divided the number of time its letter is repeating. So 4 factorial. Again for S it is 4 factorial and for P it is 2 factorial. You can write 1 factorial also for M. Now we have to find when the 4 I's not come together. So consider all the 4 I's as one letter. Again same thing as we have done in the previous question. When you consider 4 I's as one letter, so total letters there were 11. When 4 is considered 1, so 11 minus 4, remaining lattice will be 7. Now total lattice will be 7 the remaining and 1 as 4i. So when you join them, you will get 8 lattice. Now next is number of permutations when 4 i's come together. It will be 8 factorial. Now in the remaining letters, S and P will repeat it. So it is 4 factorial multiplied with 2 factorial. Now for the final answer, we require when 4 i's not come together. So in this case, we will subtract this number of permutation when I come together from the total. So it will be 11 factorial upon 4 factorial into 4 factorial into 2 factorial minus 8 factorial upon 4 factorial into 2 factorial. So here when you simplify 11 till 4 factorial, this 4 factorial will cancel with 4 factorial. Now next 4 factorial can be written as 4 into 3 into 2 into 1, and 2 factorial can be written as 2 into 1. So here cutting is possible. When you do the cutting, 4 2s are 8, then 3 3s are 9. Here 2 3s are 6. All the digits have cut. Similarly in the second, here 8 factorial and 4 factorial are nearby. So we will write it as 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial, and 2 can be written as 2 into 1. Again here 4 factorial cancel with 4 factorial. Here 2 3s are 6. Now when you multiply the left out numbers in the first term, we will get 34,650. Similarly in the second term, when you multiply the left out digits, we will get 840. So on subtracting, we will get 33,810 permutations are there when 4 i's not come together. It is very important type when you have to find that they are not coming together. Now students, you are able to solve sums related to these types. Before starting the sums given in the exercise, go through the links guided in the snap homework. Rest we will continue in our next class. Thank you.